Well, hello back again. Last time we stopped at finding out how many bits we're going to borrow from the host portion to be able to create the 8 networks that we're trying to do here. So I ended up having a space for all these networks here. Now, if your job is now to tell me what are these network IP addresses, well, here's how we do it. First of all, you have to go back to the original network IP address that we have, the big one. And as you can see here, the yellow section here represents the network portion, the green represents the host portion, and this pink version represents the borrowed bits from the host to the network portion. Now, what we need to do, basically, we're going to manipulate this pink area here. And we're going to study all the possibilities that we can have here. Oh, sorry, not study. We're going to create all the possibilities that we can have here. So basically, those 3 zeros, they can be, let me just go down and create a table for all the possibilities. I'm going to go in this area here. So let me just go ahead and create a table. Oh, you know what? There's no need. We have the first possibility to have 3 zeros. The second possibility to have 2 zeros and a 1. The third possibility is to have a 0, 1 0. And the fourth possibility is to have 0 and 2 ones. Now, just remember, there should no be duplications. And then the fifth possibility is to have 1 0 0, and then we have 1 0 1, and then we have 1 1 0, and then finally we have 1 1 1. So those are the 8 possibilities, combinations of zeros and ones we can have for those 3 pink digits that we have here. Now, if you're wondering how exactly I'm supposed to know that, well, again, since I said 8, so I'm going to have 8 combinations. And now, look at this. This is 0, 1, 0, 1, 0, 1, 0, 1. That's the first column. The second column, 0, 0, 1, 1, 0, 0, 1, 1. And the third column, 0, 0, 0, 0, 1, 1, 1, 1. And that's basically how I did it. Now, I just want to tell you, what if I had to borrow 4? Something like that. Well, I'm going to do the same thing. But first of all, let me just take out any extra spaces between them. And here, this is what I'm going to do. I am going to just put a space here just to show you. Since I have 4, that basically means I'm going to have 16 different possibilities or combinations. So there's going to be 0, and then 0. Let's just put it back. And then another 1. And then I'm going to have to repeat this. Let me just go down and put another 0. Let me just copy this. Control C. So I'll just count how many. Like 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. Let me count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay. We said we need to have 16. So I think I just need to take this one away. Let's go back. So again, I'm going to calculate here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Now in this area, remember, we're going to go 0, 1, 1, then 0, 0, then 1, 1, 0, 0, 1, 1, then 0, 0, 1, 1. I know it doesn't look really good. That's okay. Okay, now let's go ahead. The third one is basically going to be 4 zeros and then 4 ones. Well, I think I had 5 zeros here. And then I got 5 ones here. So let's go back. 0, 0, 0, and then 1, 1, 1, 1. And the final one is going to be basically 8 zeros. Then 8 ones. Let me just rearrange them so they will look a little bit better. A little bit better. Anyway, I'm just showing you here how to find the combinations of those zeros and ones. Anyway, let me just take this away. Now let's go back to the examples that we have at the top here. So I got those 3 zeros. So the first one is going to keep them 0, 0, 0. Let me take this. I think I already copied it, so I'm just going to paste it here. Nope, I made a mistake, so I'll just copy it again. Put it here. What's going on here? Nope. Let me copy this. Let me copy it from here, just in case we don't want to have any problems with the formatting. Okay, now what I'm going to do, I'm just going to come here and change this 0 to be 1. And then I'm going to come here and change this one, 0 to be 1. You see what I'm doing here? The first 0 become 1, the second 0 become 1. Now, I'm going to come to those 2 zeros and change them to 2 ones. And I'm doing this to the binary presentation for the original subnet, network IP address. And now I'm going to come here and change the first one, 0 to 1. And then, oopsie daisy. Again, I'm just putting all the possibilities of the combination between zeros and ones that I can have there. 1, 1, 0, and finally, this will be 3 ones. Okay, so here we go. Those are my IP addresses for each one of those subnets. And as you can see here, let me just go remind you about what I did here. We took the original network IP address, we converted to a binary, and then we start asking ourselves that we need to borrow some bits from the host portion to the network portion. At the beginning, the whole thing here was green. So we decided to borrow 1 bit, wasn't enough, 2 bits wasn't enough, 3 bits, that's enough. So basically those are the 3 bits are going to be borrowed. And then after that, we said we have to change those 3 bits for all the possibilities of the combination of those ones and zeros we can have. And here they are. 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. Now, all you have to do after that is for each one of them, you convert it to the decimal. And so this is going to be 192, 168. Again, I'm just doing it fast. If you don't know how to do it, go ahead and use a calculator or do whatever you want to do. And then 75. And then I got 0. Now, this is the tricky part. And I want you to look at this very carefully. Previously, the prefix was 24. Now, I borrowed 3 bits from the host portion. So those 3 bits are going to be added to the 24. So instead of having a prefix be 24, it's basically going to be 24 plus those 3. So it's going to be 27. And that's going to be applied to all of those network IP addresses. So I'm going to copy this. And of course, let me just type it 192, 168, 75, dot something, 27. Now, let's look at this. What do we have here? I need to convert this into a binary. This basically is 32, yes. So we come here and put 32. Let me just copy it just to save some time. Now this is 64 instead of 32. And again, remember, I'm converting this thing here that I'm highlighting here to decimal. And this is going to be 32 plus 64. So this is 96. And this is going to be 128. Okay. Oops. What's going on here? No, here. What do we have here? I have 128 plus 32. I'll do the math. 128 plus 32. That's 160. 160. By the way, I'm in the basement and they're playing upstairs, so if you're hearing any voices, that's not me. What do we have here? This is basically, oops, well, not you. Let's go back. This is 128 plus 64, and that is 192. And finally, this is 32 plus 69 plus 129. Let me just go ahead and use the calculator. I don't know why am I wasting my time. So 128 plus 64 plus 32. Oh, no, my bad. So it's 1, 1, 1, double star zeros, 224, 224. And that will be it. This is basically how I calculated and I divided my network into smaller networks. What I'm going to do now, after this, again, remember this is basically if I know how many number of networks do I want. Now, if I don't know how many networks do I want, let's say, for example, if you told me that I need to have number of networks, but for each network, must have, let's say, 12 hosts. So basically what I'm doing here, I'm not telling you how many networks, I'm telling you like each network needs to be able to have 12 hosts. Now before you continue, let me just go back here and ask you, talk about some concepts here. For each one of those networks that I just created here, if I ask you how many devices I can have for each network, well, the idea is very simple. It's 2 to the power of the host portion, remember that, minus 2. That's all you have to do. So this is basically 5, so it's going to be 2 to the power of 5, which is 32 minus 2, so 30. Each one of those networks basically can have 30 different devices. Now let's talk about this one. Each network should be able to have 12 hosts. If that's the case, what do? Well, number one, we need to apply the same concept that I just mentioned here. You're just going to say, how many bits do I need for the host portion? Oh, before we do that, let's just go and have a look at the original IP address. Let's go all the way to the top, which is, oh, not this one. Or where is it? I'm going to copy this. Yeah, this is the network IP address, and this is the binary representation. So let me just copy the binary representation for this. Oh, let me just go back here. I try to remember where is this coming from. Oh, this is a different example. Okay, 750. I'm sorry, I'm just a little bit lost. Let me just go back here. Where is the network IP address? Use the binary representation for the network IP address, which is, oh, I'm using 75 here, 28. Let's go back here. So this is the IP address for the network that I'm using. Okay, so this is a different story. I thought, let's copy this. You know what, let me just copy the whole thing. I'm going to use it down there. Okay, so here we go. This is the IP address of the network, and I need number. Let's just take this out. And remember, this is the number of hosts. So this is the IP address. Now, what I'm going to do, I'm going to put this back to be green. Let's just go back and put it as green. Okay, so just remember, this is the network portion, and this is the host portion. Now, what we need to do, previously, when I started actually trying to figure out how many bits that I had to borrow, I started counting from left. And this is what I'm going to do. I'm going to do the opposite. I'm trying to figure out how many bits do I need to keep, remember this word, to keep for the host so I can get 12 hosts. So what I'm going to do, I'm going to start with the equation. 2 to the power of the number of host bits minus 2 should be greater or equal number of hosts. And let's just fix this, put it in a form of to the power of 2. So basically this is the equation that we're going to use. Let's start with 1. If I pick 1 here, let's change the color here to be pink. This is going to be 2 to the power of 1 minus 2 should be greater or equal to 12. And remember, this is to the power. 2 to the power of 1 is 2. 2 minus 2 is 0, and 0 is not greater than 12. So just like we did before, not enough. Now let's copy this and try 2. 2 to the power of 2, and now let me just pick the other one. Now 2 to the power of 2 is 4. 4 minus 2 is 2. 2 is not greater than 12. Let's borrow a third one. Now 2 to the power of 3, which is how much? 6. No, my bad, 8. 2 to the power of 3 is 8. And 8 minus 2 is 6, and 6 is not greater than 12, so not enough anymore. Let's move on to the fourth bit. Now let's look here. 2 to the power of 4. Now 2 to the power of 4 is 16. Now 16 minus 2 is 14, and 14 is actually greater than 12. So now this is actually enough. So finally, what I'm going to say, I need to keep 4 bits for the host to be able to have networks with 12 hosts or less. You can have 12 or you can have 10. Less is okay, but not greater than that number. Okay, so now that I know how many bits I can keep for the host, what does that mean? That basically means the remain green zeros, are the bits that we are going to borrow from the host portion to the network portion. Now, what are we going to do after this? Basically, we're going to have to go and repeat exactly what we did here. Let me just highlight, and I'm going to put a star here. Repeat the same steps from the previous page at the asterisk point. Okay, what I'm going to do here, I'm going to save your time. You don't have to actually see me doing this, but I'm going to do it right now and show it to you, and I'm going to post this file. For now, I am done with part 2. I am going to go and talk about the VLCM because we didn't cover that yet. And once I'm done with the VLCM, basically we're done with all the calculations for this chapter. If you don't practice this, you will never get it. Let me just put it that way. Practicing is very simple. I'm going to give you more examples for you to work on by yourself. So let me just summarize what we said so far. We are talking about dividing a network into a small networks. We said here we have a fixed number of networks, okay, a fixed subnet mask, and we said sometimes you know the number of networks, and sometimes you know how many hosts you want to have for each network. Both of them are going to be treated differently, but at a certain point you will notice a kind of similarity between them. So for the fixed number of hosts, as you can see here, I got to a point where I realized that I need 4 bits for the host to remain, and that basically means the remain of the bits, the green ones here, are going to be used for the host to borrow. So basically, I will have, let me just show you this and I'm going to stop. We will have 2 to the power of number of bits borrowed. Stop here. So we will have 2 to the power of number of networks. Which basically equal 2 to the power of 4. And that basically means we will have how much? 16 network. Thank you, and I am going to complete this, and then after that I'm going to come back to explain what is the VLCM. I'll see you later, guys.